Now that we have introduced the idea of sampling, we can start to kind of make the reach into sampling error and how it affects statistical decision making in research and practice. The Revel text does a particularly good job of illustrating this, and so I encourage you to work with the materials that are available to you in Revel as a supplement to this lecture. So for now, remember that samples are drawn from larger populations, and this is reflected in notation. For example, we learned previously that mu is for the population mean, whereas x bar, okay, or sometimes it's used as m, is for the sample mean. And so when we're referring to distributions of samples, we're dealing with x bar, okay? And when we're referring to distributions of populations, we're referring to mu's. And so the population and the probability distributions use the same distribution, and use the same notation. And sampling error refers to the idea that we can expect random samples to differ from their underlying population. So the mean and the standard deviation are going to differ from mu and from sigma. And this, if that's complicated, let's move to the next slide because this is a nice illustration. Here I have my population of scores. Okay. This is a situation in which I have, these are my scores in my population, and when I add up all of those means and when I add up all of those scores and I divide by the total number of scores, I get a population parameter of 71.55. But say, for example, I pull 3 samples of size 4 out of there. Okay, so I have a 96. Okay, so I pulled this 96 out of there. Okay. And then I pulled the 99 out of there, okay, and I pulled the 56, and I pulled this at 52. That gives me a size 4, okay, sample size. And when I compute that mean, I get an x bar of 75.55. And I can see that this is not equal to 71.55. I'm off by a little bit. So to the extent that my sample mean is slightly off of my population mean, this is an indication of sampling error. Likewise, if I draw another sample of size 4, okay, from this underlying population, I can get an average of 62.25. This differs significantly more, okay, than the first sample. And then likewise, if I draw a third sample of size 4 from underneath that population, I get a different sample mean yet again. And so this is an illustration of what we mean by sampling error. The sampling distribution is the distribution of all possible sample means that we could pull from a larger population. And that's a very complicated concept for students at an introductory level to understand. But I really love this particular illustration because if we define our population as only these values, then it's very intuitive to then see that I can pull 3 different samples of size 4 from underneath that population. And those averages, once I compute them, are going to differ from the population average. And the extent to which these differ refer to the idea of sampling error.